Hello everybody and welcome to another MyMaths walkthrough, this time on gradient and intercept. So here we go, it says find the gradient and we're given 2 points. I always find it really useful to have a quick sketch. This is supposed to be a quick sketch and not anything accurate. So if I just put some axes together, let's say 0 is there, minus 5, let's say down here, so there's A down at minus 5. B is 4 across and 3 up, so B is going to be up here. Now to find the gradient of a line, you just work out how far across you go from A to get to B. So I'm going to go across 4 and then I've got to go up 8 to get up to B. So it's across 4 because it's from 0 to 4, and this is minus 5 to 3, which is up 8. The gradient of the line then is just the rise 8 over the run 4. So the gradient, which we'll call m, which it's mathematical, anyway, is just 8 divided by 4. So the gradient in this one, m equals 2. Mathematically, we have the gradient. The equation of any line is y equals mx plus c, where m is the gradient and c is where it crosses over the y-axis, so this one would be minus 5. So that's that one. Next question. So I'll just have a quick sketch again. So I've got 0 across down at minus 1, so let's say that's minus 1. So there's C. I've got D is 2, so let's say that's 2. And then minus 5 is down here somewhere, so let's say minus 5 is there. And let's put it across there. So I'll draw the line in to start off with. That was a terrible line, I missed the point because I couldn't see it. I go across, I go down to the line, so I can see I'm going to go 2 across and I'm going to go 4 down, so the gradient m is just equal to 4 divided by 2, so it's the rise over the run, but notice it's the rise and this is going down, so instead of 4 it's just minus 4, and then 4 divided by 2 is 2, so minus 4 divided by 2 is just minus 2, so the gradient of that one, m equals minus 2. Next question. A quick sketch, so we have a quick sketch, nothing accurate. Minus 4, let's say that's there, minus 1, let's say that's there, minus 1, so there's this point m, and then minus 2 can be here, so there's minus 2, and let's say 3 is up here somewhere, so we've got this point up here. Okay, so there's the line. I'm going to go across 2 to get to that point, and then I go up 4 to get to this point, so the gradient m is equal to the rise 4 over 2, so 4 divided by 2, and it's positive because the line's going upwards, so the gradient in this one, m equals 2. 2 is featuring quite a lot here. The next one, I've got a quick sketch, so a quick sketch, I've got minus 6 over here somewhere, minus 3 down here, so there's minus 3, minus 6, let's put it across here, and then I've got minus 3, and minus 6 this time, got to go a bit further down, minus 6, so across there, that's minus 3. If I join that up, so there's the line. All I'll do next is do the counting. So this is 3 across, and this is going to be 3 down. So the gradient m is the rise 3 over the run of 3, but it went downwards, so it's minus 3. And then 3 divided by 3 is 1, so minus 3 divided by 3 is minus 1, so the gradient is m equals minus 1. Okay, notice the quick sketches, so there's nothing accurate about the sketches. I just want something to visualize what's going on. Next one is a quadrilateral. So I've got to draw this quadrilateral, and I think I'll draw this quite accurate actually. So if I grab a pencil and the ruler, just some quick axes, let's have a look. So we'll go like that, and then I'll go, so I've got to go 6, so I'll maybe go axes there. Right, so let's put these points on now. So we've got minus 3, 0 for A, minus 3, 0, let's say that's there, so that's minus 3. B is at 0, 6, so 2, 4, 6 is up here, so there's 6 and that's B, there's A. 2, 4, so 1, 2 is there, and then 1, 2, 3, 4 is going to be here, so that's C, that's number 4. And then I've got, so I've got D is 1, 2, so 1, 2 is there, so that's 1 there, and then 2 on here. Okay, so that's D, let's just join them up. So we've got pencil going on. So we've got a shape there, we've got a shape there, we've got there we go, that one, and this one is going to be here. Okay, now let's have a look at the question. So gradient, the gradient, rise over run. So to get from A to B, we go 3 across, we go 6 up. So the gradient's going to be 6 up divided by 3, which is 2. So the gradient, this one's going to be 2. B to C, where's BC? BC's here, so it's coming downwards. So the gradient's going to be negative for a start, and then it's 2 across, 2 down. So 2 divided by 2 is 1, and then minus 1 because it was going downwards. CD is going upwards, 1 across, 2 up, 2 divided by 1 is 2, and it's positive because it's going upwards. And the last one, DA, is 1, 2, 3, 4 across and 2 up, so the gradient's going to be 2 divided by 4, which is a half. Is it a parallelogram? No, it's not a parallelogram, because if it was a parallelogram, not just from the picture but from the gradients, the two parallel sides would both have the same gradient. So these two are clearly parallel, but these two are not parallel, and therefore it's not a parallelogram. It is, however, a trapezium, because a trapezium has one set of parallel sides, and that's it. But the question is it a parallelogram? Answer's no. Second set, or last set even. So going over here, let's see if the camera's alright. Yep, it's okay. I'll move it around now. Let's attach the paper. Get out of the way, computer. Oh, I've done something. Hold on. Put that back on again, just so I can see what I'm doing. Right, so I want the gradient of A. So the gradient of A is, you can pick any point you want. I'm going to pick this point, I'm going to get to this point. So that's 2 across and 1, 2, 3, 4 up. So it's 4 divided by 2. The gradient of this one's equal to 2. The gradient of B is, if I pick at this point and I get to this point, it's 1 across and 3 down. So it's 3 divided by 1, which is 3, but it's negative because it went down, minus 3. Right, the x-intercept just means where does it cross over the x-axis, and you can clearly see it's crossing over the x-axis here. So that's at minus 1, 0, but MyMaths just wants the x value actually, so that's minus 1. And the y-intercept, where does it cross the y-axis, and that's at the number 2. So v0, 2, if you put in the coordinates. For the x-intercept of B, x is crossing over also at minus 1, so this is going to be minus 1. And the y-intercept, where does it cross the y-axis? It's down here at minus 3. The last question, x-intercept. Now you notice on the x-intercept, when I was saying the coordinates, for the x-intercept for this one, for example, it would be minus 1, 0. So at this point, y equals 0. So if y equals 0, when y equals 0, if I put this in the equation, I've got 4 lots of 0 minus 3x equals minus 72. Well, 4 lots of 0 is 0, so I've really got minus 3x equals minus 72, and if I divide by minus 3 and divide this side by minus 3, then I think I'm going to end up with x equals 24. So it crosses over the axis at 24. That sounds right. Right, and the y-intercept, so the y-intercept here is 0 on the x and 2 up, so x has got to be 0. So when x equals 0, what am I doing with the camera? I might just fall off the page now. I'll just pull this down a little bit. So what have we got? We've got 4y minus 3, lots of zeros, equals minus 72. So 4y, because that's nothing, equals minus 72. I just divide by 4 over here, and I get y equals minus 18. Half of 72 is 36, and half of 36 is 18, so just minus in front, equals minus 18. And that's it for gradients and intercepts. Have fun.